So this is problem 11.1, and right now, just read the problem yourself because I'm not going to go through that. And yeah, so this is the solution, but I will work through it later on in the video. Oh, and as a note, I didn't plug in all the numbers because you don't need to see me do that on the calculator. So the equation for your flux is going to be integral of b dot dA. Alright, well, your dA is coming out of the page, and then your b is also coming out of the page, so they are parallel, so this checks out. So since your area is constant, you get flux is equal to, you actually get BA, you just get BA. And you don't want to integrate your B because your B changes independently of dA. And yeah, so you get, what's B? B is 2e to the negative 4t, and area is 0.3 squared. So you get 0.18 e to the negative 4t. So that's your flux. So for B, your current, okay, due to Lenz's law, because your current is actually decreasing, that's the same as having the magnetic field going into the page. So according to Lenz's law, your induced magnetic field will be coming out of the page. So to do that, you would want a counterclockwise current. Yeah, so you produce flux out of the page. So you produce a B out of the page. So counterclockwise. And then for C, your E induced equation, this is from your equation sheet, is equal to negative d flux over dt. Alright? So your flux is from A, and so you just take the derivative of that, so you get 0.18 d e to negative 4t over dt. And then so you get what? Oh, and there's going to be a negative sign in front of that because, yeah. So negative, and these cancel out. 4.18 e to the negative 4t. And I'm just going to leave it like that because you can use a calculator. So you're trying to find the current, right? So V is equal to IR, so E induced is equal to IR. So your I induced is going to be E induced over R, so it's going to be 4.18 e to the negative 4t over 6 ohms. Alright, so for D, you're trying to find the total energy. So you want to start with your power equation. Power is equal to IV. And if you just manipulate your variables from V equals IR, you get power is equal to V squared over R, which is also equal to E induced squared over R. So power, another way of writing power is actually du over dt, because it's joules per second. So if you do this, du over dt is equal to E induced squared over R. You just integrate both sides. You want to integrate from 0 to t. You could take an indefinite integral, it doesn't really matter. And you want to integrate this from 0 to infinity. So plug in everything and you get u is equal to 0 to infinity of 4.18, that's a 0.18 e to the negative 4t, and all squared over 6 dt. And then just solve for that, you get your u is equal to whatever answer is in the back.